logarithms. Sort of. It's exponentials and logarithms. They go together. So if you look at this first graph up at the top, this is the graph of y equals 2 to the x power, which is kind of the parent function for an exponential. Because the bases can be different, we don't really have a parent function, but I would say this is basically it. They ask us for what value of x is f of x equal to 20. So it's kind of hard to tell, but if you were to go up to 20 and draw a line across, what do you think the f? What do you think the x would be?
Is it a decimal?
Yeah, I think it's, and it doesn't look like it's quite.
It's gonna be like
4.5.
5.2.
No.
It's not at 5.
Yeah.
Oh,
5 is the
right.
final line. So 4.2-ish or around there. I don't know. It doesn't look like it's quite halfway across to me. So I don't think it's at least at 4.5.
We put the approximately thing on there?
Oh, yeah, you can put that's good. You can make your lines wavy because we're just guessing. Okay, so then they say we could use our table. So I'm going to go to y equals and plug in 2 to the x power. And then on my table, they said use a table to approximate the solution to the nearest hundredth. How many decimal places is hundredths?
2.
2. So I'm going to go to table settings, and I'm going to count. I know it's around 4, so I'm going to start at 4. And then I'm going to change my delta table to count by 0.01. And that way when I go to my table, I'll have 2 decimal places. All right, there's 4. And I'm going to scroll until it hits 20. All right, so right there, 4.32 is 19.97, and then 4.33 is 20.11. So on my table, it doesn't actually show 20. 4.32 shows 19.97.
Oh, is that why my calculator was like that?
Yeah, probably.
This is going to take forever.
0 then.
What?
Okay. Or the other way that we could find it is to do an actual intersect. So on y equals, I'm going to plug 20 in. I am going to have to adjust my window because your normal window only goes up to 10. So obviously, the only thing you really need to adjust is your y value, your y max. So I adjusted my y max to 25 so that when I hit graph, my line at 20 will show. So here's my exponential, there's y equals 20. If I do an intersect right here, second trace, find the intersection. .3219281.
Whoa. How did you draw that so fast? Huh?
I'm pretty sure we see what she does on the line.
All right, so, but all of those just gave us kind of approximate answers. And none of them were the most accurate way of doing anything. So the question asks, is there a way to solve algebraically?
Possibly.
Yes, there is. So when we solve something algebraically, what we use is inverse operations. So this is just like way back in Algebra 1, if you had x plus, like right down here, they have n plus 4 equals a, and I'm trying to solve for n, how do I get n by itself?
Minus 4.
Subtract 4, right? So if I subtract 4 from both sides, I end up getting a minus 4.
A minus 4.
That's using an inverse to solve. So the inverse of multiplying by 3 would be dividing by 3, right? So I would divide both sides by 3, and that would give me a over 3. So this one is, the operation is squaring, so n squared. And if I want to undo that, you're exactly right, I would square root both sides, and that would give me n equals the square root of a. So the inverse of an exponential is a logarithm. Don't put that in. Hold on. Alright, a logarithm is an operation, just like adding, subtracting, multiplying, and dividing. So just because it's a word, and it is a word, it's almost like they ran out of symbols. You know, they used the little line and the little line dot dot for division and the X, and it's like they had no more symbols anymore, and they were like, hey, just put the word log there. But when you see the word log, it's actually an operation. And it has to have something following it. We'll talk more about that in just a few minutes. Okay, so logarithms are the inverse of exponentials. So, they are inverses. So when something is an inverse, if a function is an inverse of another function, they gave me the table of an exponential. How can I find the table of the logarithmic?
Put it in reverse.
Put it in reverse. You switch the x and the y column.
Did we do this last year?
Should have, yes. The entire first semester of pre-cal is a review of algebra 2.
Oh,
Except for some of you did not get to this, and I know that, which is why we're kind of going slower on this part. Okay, so they already graphed the exponential. That's what this is in black. So let's go ahead and graph the logarithmic. So 0.25, that's a fourth. Okay, 2. All right, so then it asks how do you read and write logarithms and what do their symbols look like. So looking at the exponential that they wrote first, right here. What do we call this piece that the exponent is attached to?
Coefficient?
Coefficient is in front of a variable,
The base?
the base. Anything that an exponent is attached to is called the base.
Should've known.
It is still called the base, but on the logarithm it's going to be down below the line. So the base is the base is the base. And then next to log is going to be a value that we call the argument. Now, this is what I was talking about a minute ago. Logarithm always has to have that value. The base is always there. However, on our calculator, we have, we'll talk a little bit more about common log in a minute, but it doesn't show the base because we all know what the base is. So this one doesn't show the base, but when the parentheses pops up, that is for the argument. You cannot take a logarithm without an argument. It has to have one. It'll never just be the word log. It's always log and then something following it. Now, the calculator is always going to put parentheses. Sometimes, and I haven't checked Delta Math, but some tests put the parentheses, some don't. Sometimes it depends on what they want to go inside of there, and it's all about trying to keep it clear for you. But there's always something following the word log besides the base. And that's called the argument. And then what's over here is going to be the exponent of the exponential, but it's actually the solution of the logarithm. So that's where x goes. Now the way we would read this, so I'm going to write it right here. So this is, you would read that as log base b of a equals x. is to solve an exponential. It's to get x out of the treehouse. See, the whole point of algebra, since you guys first started learning, is to get x by itself, right? To solve for the variable. But we can't solve for it if it's up in the air. We have to get it out of the treehouse and down onto the line. And that's what logarithms do. They get things out of the treehouse for us. So the first part of this, and all we're going to do today, is rewriting a logarithm to an exponential and an exponential to a logarithm. You just have to learn the order. So if we look at A, this is an exponential base of 7. The base is always the base. It's a big base on an exponential. It's the little base on the logarithm. So it's going to be log base 7. And then the other two pieces change places. The answer of the exponential becomes the argument, and the exponent becomes the solution for the answer. So it's like these two pieces swap. Whatever's with the base when it's an exponential can't be with it when you rewrite it as a logarithm, and vice versa. So on this next one, this is going to be log base 3. And right now the 3 has a 5 with it. So it can't keep the 5. They're not buddies anymore. This is going to be log base 3 of 243 equals 5. So those other two pieces swap.
It can't be a fraction, can it?
Can what be a fraction? Which thing?
Like where the 243 and the 49 are.
They can.
They can? Okay.
Yeah. Sometimes we adjust them to make them not. What it can, the only thing it can't be is negative.
Oh, okay.
The argument can't be negative, but other than that, it can be anything. Okay, so this is going to be log base 6 of 1 over 36 equals negative 2. Is everybody okay?
Hang on. Yes.
All right. So what's this next one? Log base what? All right. Log base 9 of 27 equals 1.5. All right. So y'all do E, F, and G real quick. All right, so starting on H, now we have to reverse it. Now they're giving us a log, and we've got to go to the exponential. So the base is still the base. So now it's just going to be a big 2. 2 to the x equals 64. So before I go any further, what would x be? If 2 to the x equals 64, 2 to the what?
6.
Yeah, 2 to the 6 would be 64, so x equals 6. So this one, but what's your base going to be on I? X. So this one's going to be x squared equals 64. Well, what squared gives you 64?
8.
8, so x would be 8. And this one is 64 squared equals x. And that's a really big number, so I don't care what it is, because I'm not going to write a really big number like that. But you could just put it in calculator. Are y'all good?
Yep.
So this is not hard, huh?
No.
And there will be, these kind of questions will be on the test, where all you have to do is just, not even like these where I just made you find x, but even like the ones where all you have to do is rearrange it, and rearrange it, that's it.
That
Because
should just be a little.
it's kind of important.
Should give us a test on just this.
Yeah, I promise you, my college algebra class took a test on this morning, and you can ask them. It was pretty easy. This is it's a pretty easy concept if you've been taught it, but I just knew that some of you hadn't learned it, so. Okay, so the next part is common log. So back before we had calculators that we could program to do a kabillion things, like when things had to be really big in order to have a lot of memory, they built one logarithm into the calculator. And so we all did all of our logarithms the same way, and we had these big logarithmic tables that we could go to and look stuff up, and we were looking at everything with the same base because we didn't have calculators that could change stuff for us. So that base that's what we call common log, and it uses a base of 10. And everybody all over the world used it. So because it was common, they didn't write the base down there anymore. And they still don't. So if you see one like this, log and just a number, that's log base 10. So on this calculator, we have a log button, and that's what it is. That's why when I hit logarithm, no base comes up because it's log base 10. It always is. Now, these calculators have, you can see it kind of, but it's turned off because they put these into test mode. All these calculators are in test mode now, but you can see number 5 where it says log base. They have programming now where I can put whatever base I need to in my calculator, and when it pulls up, it's log, and it has a little place that's dotted that you put log base 3 or whatever, and then the other place. But we didn't used to have that, so that's what common log is, and that's what the button is for. It's just common log. So you just need to know that that's log base 10. There's another log button on there too. We'll talk about it in a few days. But if they ask you to rewrite this one, just don't forget that it's log base 10. So this is going to be 10 squared equals 100 because the base right here will be 10.
So no matter what, if like there's no base, it's always a 10?
Yeah.
Okay.
So this one is 10 to the negative 3 equals x.
It's 1,000, right?
So that would be,
No, negative 1,000, right?
yeah, it would be 1 over 1,000, so it
Oh,
would be 0.001. And this one would be 10 to the 4th, 1,000.
Wait a secondento. The last one confused me. I don't know, where'd you get the 10?
That's what you just said.
Right here.
Okay, it didn't register in my brain.
If there's no base written, it's a 10.
Oh, okay, that would make sense. Okay, sorry.
Okay. So this one, same thing. Don't confuse. So this is why sometimes I think they put the argument in parentheses because it's confusing. But that's the argument. So this is log base 10. So it's 10 to the x equals 1 over 10.
Okay.
Are we good?
Yes.
Awesome. Okay.
Assignment?
Yep.
Yeah.
The way all
Wait,
of
this
them.
stuff is easy. Why is it